right now. Right now, we have to learn basics of the proportion analysis. What does it mean, basics? First, we have, well, uh, 1 month ago, we learned how to find confidence interval for a variable, for a continuous variable. For example, we could find confidence interval for the market return or for the average weight and so on. But what about proportions? Is it possible to find a confidence interval for proportion, and why or when we have to find such a confidence interval? A good illustration where we can calculate confidence interval for proportion could be related to fixed income instruments. Well, you can try to predict, you can try to, not to predict, probably you can try to estimate the interval of defaults in your potential portfolio. Well, it could be done using confidence interval for proportions. Another example where we can work with proportions and confidence interval is for sure analysis of the quality of something. Well, so you can calculate a percentage of defeated products, or you can calculate confidence interval of the defeated products instead. Another important application as we speak about confidence interval is hypothesis testing. As you know, you can run one sample test, two sample tests, as we can compare our sample proportion with a single number, with an arbitrary number. Well, for instance, is it true that proportion of defeated products is greater than 0.05? Or we can compare two proportions. For instance, is it true that two assembly lines produce products with a comparable quality? Well, and today we have to learn all of this stuff. Well, for sure, I'm going to show you theoretical concepts and how to run all of these computations in Stata. Well, so first let me share my screen to show everything. Well, all right, proportions. Do you see my screen? Yeah, we do. Oh, thank you. Well, first, please remember, when we work with proportions, all of our steps actually are the same. We have to start with the formulation of the null and the alternative hypothesis. And likewise in previous tasks, we have to deal with population parameter. Now population parameter is P. When we worked with continuous variables, our population parameter was mu, if you remember. But now it is P without bar. And sample statistics, the counterpart sample statistics is P with bar. This is our sample statistics. Well, and let me remind that null hypothesis should be a statement concerning a parameter that includes the equality. So put equality in the null hypothesis. Well, next you have to determine, or you have to ask for significance level. Well, is alpha. Well, and finally you have to make a decision whether you should run one-tail test, two-tail test. Well, and it depends on the alternative hypothesis and the task given. Well, I suppose all of these points are familiar for you, and it's not difficult to, for you to formulate such a hypothesis. Let me remind that when we have equality and inequality in alternative hypothesis, we work with two-tail test, and once we work with inequality, strict inequalities in alternative hypothesis, we deal with one-tail test. A one-tail test could be upper tail test as when we work with greater operator, or lower tail test if we deal with lower operator. That's it. And again, let me stress that when we formulate hypotheses, we always use parameter instead of statistics. We frequently ask about this in our exams, so pay attention to this detail. What else? Okay, imagine that you formulated hypothesis, you know what you have to test and what hypothesis you have to reject. Well, But to run this test, we have to learn what proportions are or what qualitative variables are. Well, uh, well, what does it mean, proportion, in our context? Well, imagine that, no, the simplest case is a case of a binary variable. Binary variable is a variable that takes two values, 0 or 1. And if the value is 1, we say that it is a success outcome. And if the value is 0, we say it is failure outcome. Well, for example, customers like or don't like a new product. It could be a binary variable. If customers like is we enter 1. If customers don't like, we enter 0. Well, hence we repeating this again and again for each customer, we can create a binary variable. And well, um, another example, items manufactured are defective or non-defective. Well, for instance, I could use 1 to denote defective item and 0 to denote non-defective items. Well, please remember that always when you work with binary variables, they must take two values, 0 and 1. For sure, in reality, it could be so. These numbers could be different. Often, if you download dataset, you will see that all binary variable have 1 and 2 values instead of 1 and 0, and it means that you have to replace number 2 by 0, or you have to make more replacements like, well, um, okay, next. Um, Imagine that our variable is binary variable. It has successes, failures, highest ones and zeros. Well, and uh, how can we find a simple, I suppose, confidence interval, or how can we work with simple statistical tests? Well, once we so first we can create a construct. So if we, for instance, run a test, we can find a rejection region using this formula. I will explain this formula in detail in my next slide. Well, um, first let's discuss tests, not confidence intervals. Well, how to run a test to check whether our proportion is different from a single number. First, you have to find a sample proportion. To find sample proportion, you have to divide number of successes to the total number of observations in your variable. ISX is your successes, N is your successes plus failures. Well, it is your p-bar, it is your sample proportion. Well, next you have to calculate a test statistics. In the numerator, you should find a difference between sample proportion and your hypothetical value, and the denominator, you should put standard error of the proportion. This is standard error of the proportion, and it is easily calculated like p in brackets 1 minus p divided by n. Well, and once you calculate that value, you should compare it with uh, uh, the critical z value, or you can find p-value. Well, and the rest part of this exercise is the same as we did with that test. Well, if that is greater than that critical, you have to reject null hypothesis. Otherwise, you don't have to reject it. Well, example. Please read this example carefully and type in the chat uh, a sample what and calculate sample proportion, please. Type in the chat and calculate sample proportion. Okay, let's check. Okay, good. Well, now, yeah, 0.06 is the right answer. Now, formulate null and alternative hypothesis. Type in the chart your null and alternative hypothesis. Type in the chart null and alternative hypothesis. Okay, not bad. Not bad. Well, look, keyword here that the proportion of dissatisfied customers is less than 0.1. Less means it is a strict inequality. Okay, good. No, at least I see that all of you use equality or purity null hypothesis. Not bad. Probably there are some mistakes with inequality operators. They must be different, but most of you gave right answer. Right. Well, and the answer is this. This is your null hypothesis. An alternative hypothesis. For sure, we have to test work with proportion, and alpha is 0.1. That's clear. Well, this is your alternative hypothesis. Again, why we have this operator here? Because we have a keyword less than. It is a strict inequality, meaning less. Well, okay. Next, we can find rejection region. Well, this is, we can apply our formula, and this is always estimated z statistics minus 1.33. Well, and what we have to do next? Next, we have to compare our estimated z value with its critical value. The critical value, it is minus 1.28. Once we see that our estimated value is smaller than our critical value, we have to reject null hypothesis as we did in this example. Well, now let's repeat this exercise using Stata. Please, everyone, open Stata. And if you open Stata, press plus to indicate that you are ready for Stata exercise. Open Stata and press plus if you are ready. All right, thank you. Well, let me share the whole screen. Well, let's go back to the task and let's use Stata. Well, in Stata, as you know, we have different calculators to check yourself when we work with exercises from the textbook. And now we have to use a Stata calculator. And as usual, we should go to statistics, summaries, tables, and tests. And here we have to click on classical tests of hypothesis. And in this list, you should find proportion test calculator. Please find proportion test calculator and open the window. Please click proportion test calculator. Look, this is prtest command. Well, wait. And now we have to, all of you have empty spaces here. Well, and now we have to fill this interface. First, we have to make a choice whether our test is one sample or two sample. It seems that our test is one sample because of our null hypothesis loop we work with. And because of our task, we work with single sample proportion and we need to compare it with single number. Well, next we have to enter sample size 100. Next, we have to enter here sample proportion 0.06. Next, we have to enter hypothesized proportion. Well, this is, well, 0.1. And confidence level, it is 0.1, hence we should use 90. And click submit. On this. Well, and look, now we have exactly the same Z statistics, and we have different p-values. Well, for sure, if we now we have to find right alternative hypothesis. It is our left alternative hypothesis, and we see that we have to reject null hypothesis at 10% confidence level. But if we set another confidence level, for example, 5% or 1%, we cannot reject null hypothesis because our p-value is close to 0.1. For sure, if we test this alternative hypothesis, we cannot reject null hypothesis because p-value is large, and the same can be said about this alternative hypothesis. What else? What else we have here? Here also we have our sample proportion, its standard error, and we have a confidence interval for this proportion. And we see that this confidence interval is large, and in fact, so this is 90% confidence interval, and our hypothetical value isn't inside this confidence interval, but its upper limit is close to our hypothetical value, meaning that our p-value must be close to 0.1. Well, this is a simple way how you can check yourself and test proportions. Well, questions? No questions. Okay, good. So now we have to go on, and we should try to maybe discuss the same example. We discuss assumptions and two sample tests. First, please remember, when we work with hypothesis tests and we work especially with proportions, we should check whether our sample is sufficiently large. What does it mean that our sample is sufficiently large? It means that number of successes, if we deal with one sample test, number of successes cannot be smaller than 5. So 5, it is a minimum number of successes. No, I would say that so your textbook states this is a rule of thumb, and so if you have less than 5 successes, you cannot run the hypothesis tests. But in reality, 5 successes also it's too small to make a reliable test. Especially it depends on because it depends first on number of values and number of, especially if you work with two populations. Well, please note that number of values also cannot be less than 5. But moreover, if your sample consists of 10 cases and you have highest 5 values, 5 successes, it cannot be sufficient for you because, well, now we have large data sets in our reality. And usually our threshold is, so we try to rely on larger numbers if we can. But anyway, if you have such a question in exam, please say that number of successes cannot be less than 5 and number of failures cannot be less than 5. In one sample test and two sample tests, each sample cannot, so each sample must have at least 5 successes and at least 5 failures. Well, please remember this assumption. What else? For sure, it is possible to calculate and to run 2 sample tests. Well, and likewise, working with 2 sample tests, there are different ways to check whether 2 proportions are different. Or to compare two proportions. No, the simplest way to check whether proportions are different is to find their confidence interval. Well, you can calculate it using this formula. And look, this formula, by the way, is easier than a formula for a continuous variable. Well, another way for sure is to run a test. Well, no, don't read it. Let's, yeah, is to run a test. And to run a test, as usual, you have to formulate hypothesis. Your hypothesis could imply two-tail test, I is equal or unequal, or it could be one-tail test. So as alternative hypothesis is about less or greater than 0. Well, there are 2 ways to formulate hypothesis in our context. So one way is to work with zeros. Another way is to work with a simple comparison of 2 population proportions. And the principle of this test actually is the same. You have sample distribution of proportions. Well, and you should check whether your estimated statistics is inside white region or outside this white region. And in principle, that's it. Well, to find, to test, to compare two proportions, you have to find that value or that statistics. Well, to do this, first you have to find pooled estimated of the overall proportion. Well, and next you should calculate that test for difference between population proportions. Well, and no, fortunately, all of this stuff is automatically done in Stata. But now let's try to read this task and let's discuss how to solve it and how to repeat it in Stata. Please read this task first, and if you are ready for the discussion in Stata, press plus. Read this task, a critical component of a Well, I hope you are ready. So, look, Here we have a small table. First, we have sample sizes and we have number of positive successes. In the first sample, we have 55 positive successes, and in the second sample, we have 75 successes. Let's recall our assumptions that state that, and our assumptions state that number of successes cannot be less than 5 and number of failures cannot be less than 5. And indeed, 55 is greater than 5 and 75 greater than 5. Hence, moreover, if we calculate number of failures, you will see that this number is greater than 5. Hence, we meet our assumptions. What does it mean? It means that our proportions, can be normally distributed if we repeat this experiment again and again. So now I'm talking about sampling distribution. So and sampling distribution of our proportion is close to a normal one if we meet our assumptions. Once we know our number of successes and failures, well, we can easily calculate sample proportions. Sample proportions are 0.22 and 0.30. Well, and our job is to check, okay, we know that 0.22 and 0.30 itself themselves are random numbers, and we have to check whether we have to use these two random numbers to check whether population proportions are different. Well, I asked whether second proportion is greater than the first proportion. Well, to do this, we have to calculate first bullet proportion. It is here. Look, I recommend you to start with the bullet proportion because you have to use it in the estimation of that statistics. And what I have to do, I have to apply a formula. And my output is 0.26. Once I have such a number, I need to calculate Z statistics. Well, and here I have to find a difference between two sample proportions. Well, and next I should use my bullet proportion to calculate bullet standard error. Well, and once I calculate the numerator, I can estimate that statistics. And what I have to do, I have to use critical value of that statistics. It is minus 1.645, and to compare my estimated Z with its critical value. I see that my estimated Z is smaller than critical value, hence I have to reject null hypothesis, and my conclusion is that the second proportion is greater than the first proportion. Well, no, for sure it is fairly easy to make to do all of these calculations, but what could be difficult for you is interpretation. What now? You have a solution. Type in the chat, how would you interpret our output for the general audience? But imagine that our audience doesn't know statistics, statistically significant results, new hypotheses. Our audience is unfamiliar with these words, but you have to explain what we found with this test. Type in the chat your version of simple interpretation. the new motor header is less. Not bad. Well, I expected that. Well, not bad. Well, how to explain it using simple terms, guys. So, let me give you some life hacks. First, try to avoid new words like efficient, effective, and try to use the same words as you see in your tags. For example, the null hypothesis states that the new motor heater is no better than the old or current motor heater. What you have to do, you have to tell whether, for example, that new motor heater is better than the old one. And that's it. Just one short simple sentence, or you can say our research shows that new motor heater is better than the old one. That's it. Well, no, reliable could be also, I suppose. Well, could be also, and because this word exists. Well, again, okay. Well, again, don't if you want to translate all of this stuff into managerial language, don't try to avoid using new words. Use simple sentences. You can start with our research shows and try to reformulate what your hypothesis, it could be neural alternative hypothesis of interest shows without statistical terms. That's it. Okay, I suppose that's it with the theory, and now we have to work with data. Questions? All right. Now let me send you our data set for this lecture. Well, our data set is from Global Entrepreneurship Monitor. Probably you heard about it. Well, it is a well-known study of entrepreneurs. Well, sample. Second plus. Now everyone, please download this dataset and open it in Stata. If you are ready, please press plus. Open this dataset in Stata and press plus to show me that you are ready. Okay, let's wait a minute. Well, let's start. So, it is a almost real data set. Why I mentioned, so why almost real? Because I did some transformation. I made some transformations to make it easy for you. Well, but these transformations are small, and in fact, these data sets, especially variable names, their labels, are real. This data set covers different countries, and it shows entrepreneurship activity in these countries. Well, and when we work with qualitative variables, we often work with common tab. Well, this command always requires varlets, and it has also nice um, options, which we will learn for sure in this course. But now let's discuss this data set. And to discuss this data set first, so I recommend you to find a variable country. Let's check what countries we analyze using this data set. To find out it, you should type tab is table and country. Well, we have two countries in this data set, Latvia and Estonia. Sample sizes aren't very different. Latvia has 2,000 cases, Estonia has 2,300 cases, well, and in total we have 4,300 cases. Well, and in addition, we have a lot of different variables. For instance, your survey was administered weights if you want to calculate weighted variables. And we have various interesting variables. For example, one of the key variables in GEM study is tier YY. If I type desk tier YY, I will see its label. I will see that this variable shows whether a person is involved in a total early stage entrepreneurial activity. Well, also in this table, I see an interesting information. First, I see that there is a column storage type. What does that mean? It shows that my variable is byte. If my variable is byte, it means that my variable is a binary one. Display format, it is a format to display numbers. So it display number. So it means that it display numbers and as a whole numbers. And also we have a column value label. And what does that mean? Our variable has labels. For example, if I type top tier YY, I will see its label no yes options, no yes answers, and some numbers. What I have here, I have total number of no answers. I have the number of yes answers. I have percentage of both answers. For instance, in my sample, 14% of people answered yes, and I have cumulative percents. Well, for sure. So I mentioned that we have some nice options, but well, for sure these two answers don't look like numerical information, and someone can ask me how can we analyze a variable without numerical information. But note that in fact these two words in fact are labels. For instance, if you add an option no label, you will see that instead of yes and no, status shows 0 and 1. It shows that, in fact, it is a binary variable. And how binary variable, how all binary variable are recorded in Stata or other statistical packages. When we work with binary variables or factor variables, if you prefer RStudio, you will see text information instead of numbers. But in fact, this text information is just a label. For example, let me show you how it is recorded in Stata. Wait. Look, this is my spreadsheet with a single variable. Let me enlarge my font. Well, I have no here, yes, so I have some text information, but well, color of these values is blue. What does it mean? It means that in fact it is a number, it's not a text information. And if you find value row here, you will see that value of now is 0, and if you click on this cell, you will see that its value is 1. Or if you click on edit mode, you can make a double click on any value in your spreadsheet, and you will see that instead of a text, in fact, it is a number. Here it is 0, here it is 1, and so on. What does that mean? It means that well, when we create a binary variable, first we create a set of zeros and ones. Once we create a set of zeros and ones, we assign labels to these numbers. We tell Stata, well, 0 means no, 1 means yes. For sure, we can in other words, for instance, instead of no, we can write paid worker. Instead of yes, we can write entrepreneur. Well, for instance. But anyway, if this variable is blue, it is a binary or a qualitative variable. Well, what else? We also can use tab command to check whether this variable meets our assumptions. Well, we see that both numbers are greater than 5, hence our assumption is hold. What else? Also, we can easily introduce if operator you are familiar with. For instance, if country is Estonia, wait, probably. Okay, yeah. Yeah, one important remark. Sometimes, well, country names are string variables, as it is a text information. Sometimes we need to look at value labels because it could be a binary variable, but codes are different. Look, instead of Estonia, I have to type 372. Well, and Stata will recalculate my total entrepreneurial activity for Estonia. Well, and Estonia, we see that there are 16.4% of adult population involved in early entrepreneurial activity in Estonia. Well, another way to describe qualitative variables is to use summary command. For sure, we can use it. Some TRYY. But you have to be careful with such a way to describe your binary variables. First of all, it is pretty easy to interpret mean. Look, mean, in fact, it is a percentage of successes in your variable. Look, this number is 0.14, and if you look at your top output, you will see exactly the same number here. So these two numbers are the same, and they show proportion of positive or successes in your sample. But unfortunately, in some output, we cannot interpret standard deviation. This interpretation, in fact, doesn't make sense, and it doesn't show standard deviation of the proportion. We use another formula to calculate standard deviation of the proportion, and it is beyond this our cost. Also, minimum and maximum values cannot tell us anything interesting because, well, they showed just two possible outcomes in our binary variable 0 and 1. Well, but for sure we can make our summary statistics easier for interpretation if we apply I operator before the variable name. If I apply I operator, my table will be similar to top output. It will show percentages of so values and successes, but again I cannot interpret standard deviation, and it doesn't show so how many values I have for how many successes I have. Hence, this table is better for descriptive statistics. And in our course, I insist that you have to use this command to describe our variable. And to make a good descriptive statistics, again, dear students, please rely on tab command instead of summary when you work with proportions. Now, questions. To sum up, please remember that all binary variables have value labels or can have a value label. Next, second point, please remember, always it is good to start our analysis with the descriptive statistics, and instead of summary command you should rely on tab command. Don't use summary command because it's not convenient and it can lead you to wrong conclusions about the variable. Instead, it is better to use tab command. For example, if you look at summary, you can easily state that our assumptions are met, but probably in fact you don't meet our assumptions. Well, okay, so we can use tab YY. And what else? Also, we can find a confidence interval for our proportion. For example, we want to find a confidence interval for the percentage of entrepreneurs in both Estonia and Latvia. To do this, you should go to statistics. In statistics, you should click summaries, tables, and tests. Classical test of hypothesis. Or no, summary and descriptive statistics. And here you should find proportion CI calculator if you have a task, if you have an exercise in your textbook, or you can rely on confidence interval if you have a data set. Well, please use these two options depending on what you have. Confidence intervals, because we don't have a task, we have to proceed some spreadsheet data. Well, and now we should wait. Well, we should set that we work with proportions. We should set variable name TRYY, and we should set confidence level. Confidence level, let's use the same. And one important note, please here use volt, because there are 5 options to calculate confidence intervals, and all of these options rely on different formulae. By default, Stata uses exact Klopper-Pearson method to calculate confidence interval for the proportion, but your textbook and we in our course, we will use volt confidence interval. And especially in the exam, don't forget to click volt or to use volt option when you calculate proportion confidence interval, and click submit. Now, everyone, do the same, please. Wait. Here, YY proportions. Something go wrong. Must work. Wait. So I'm not sure, but it seems that my Stata did a program error, because, well, it should work. But if we can calculate it using calculator. But if we rely on proportion calculator, so sample size is 3 and 612 volt. Yeah. So if we rely on a calculator, we will calculate. So static can calculate it. In my case, your status should calculate both, I think.
I have the same error.
Same.
Yeah. So
Wait, what version I have? That's strange because yeah, it should work. No, okay, it doesn't matter anyway. We rarely use it. Well, if you can reach actually the same output using calculator. Just enter sample size in number of successes and set here volt output. Well, this is simple confidence interval, and we interpret it as usual. Well, so this is a way how can we fix this bug. Well, no, okay. Fortunately, we rarely rely on proportions when we work with. We rarely rely on confidence intervals when we work with proportions. Instead, we often compare proportions with a single number or compare two proportions. How to compare two proportions when we so I ask how to run a test. You have to go to classical test of hypothesis and go to proportion test. And when we work with proportion test, well, you have five options. First, and the simplest option is a variable. So you have to choose our variable, for instance, dir y, and hypothesize proportion, for example, 0.2, and click submit. Well, so this procedure is very easy. You have to choose a variable. You have to enter a number you want to compare with, confidence level, click submit. For sure, you can use second tab by fn. For instance, well, if country equal 372, for instance, we want to run our analysis for Estonia only. And if we enter this statement here, we will rerun our test, or you can use your command line. Try to run this test, and well, also you can compare it with 0. Well, oh no, not 0. Yeah. Well, yeah, and let's compare it with 15. Well, what else? Look, here you have some probably interesting outputs. You have confidence interval, Z statistics, p-values, everything is the same. Similar to t-test and z-test we did so a couple of months ago. Well, no, for sure, again, comparison of two, so of a proportion with a number, it's not a typical exercise, but what we do often, we compare two proportions. Well, for example, we want to compare entrepreneurial activity in Estonia and Latvia. To do this, you should go back to PR test, and now you have to use to sample using groups option. And again, you should use a variable name. It is TRYY. And let's use group variable name is a country name. And click submit. Oh, wait. Yeah, should be. Well, sometimes we have such a problem. Takes on one values, not two. When we have such a problem, you should transform your variable. This is an interesting and important exercise for you. Look, if you want to group your variable or you want to run your analysis by group, you should create a new binary variable which shows whether your sample belongs to one group or another group. Well, this variable looks like a simple binary variable, but if you look at its label, you will see that its label is 371 and 372. For Stata, when you have such labels, it is unclear for Stata that you deal with a binary variable. Stata reads it as a continuous variable. Well, and you have to create a binary variable. Now let's create it together, and let's create a variable. Let's generate a new variable, for instance, Estonia equal point. What does that mean, equal point? Equal point means that we create an empty variable. If you scroll down in your variable list, you will find a new variable Estonia. It doesn't have any label because we didn't assign any value label, and it also empty. If I describe Estonia, my output will be empty. Well, now I have to fill my guys. Do the same, please. If you are ready, say something.
Yeah, we are ready.
Yeah, thank you. Now we have to fill our new variable with some values. You have to replace Estonia with 1. You have to replace missing with 1 value if 3 is double equal 372, as if our country is Estonia, our binary variable must be 1. That's it. And look, we have 2,300 real changes. Exactly the same number we have here or here. So it means that there are no mistakes in this code. Next step, you have to replace Estonia with 0 if our country is Latvia. 371. And look, we made 2,000 changes. Now you have to check yourself. Tab Estonia, describe a new variable Estonia, and please reach the same output. If you are ready, please say something or type plus. Good. Okay, good. Very good. Okay. Well, now we can go back to our test. Yeah. Oh, no. Now we have to assign a variable label. Look, here, or if I type describe Estonia, I don't have variable label. But what if I want to enter here some text? To do this, I have to type label var variable, next variable name. Now I am telling to Stata, please assign a label to my new variable Estonia, and in quotations write any text you want. For example, Estonia, if yes, no, country, if Estonia 1 if Latvia 0. That's it. And look, now you have variable label. Now we can run our test. And we have such an output. Well, what we have here? Here we have two confidence intervals. Note, I mentioned that we rarely calculate confidence intervals using our command, which doesn't work in Stata. Well, because in fact, when we run a test, when we compare two proportions, Stata calculates everything we need. It calculates confidence interval for each proportion. It calculates confidence interval for the difference in proportions, and it runs the test. And by the way, we often compare so different groups, so different proportions using different groups. What we can learn from this test, we see that our confidence interval for the difference has two negative limits, and we don't have 0 in this confidence interval. Also, we see that that statistics is definitely greater than any usual critical values of that statistics, meaning that we have to reject null hypothesis. And our p-values confirm this fact. They confirm that we have to reject null hypothesis, and we see that in fact, so that the difference is negative, meaning that so percentage or proportion of entrepreneurs in Estonia is greater than in Latvia. Or simply speaking, our research shows that there are more entrepreneurs. Our research shows that that entrepreneurial activity is higher in Estonia than in Latvia. That's it. Questions?
Can we
No question.
Can we conduct our proportion test if our proportion variable has string type, not factor, but string?
No, because if your variable is a string variable, Stata will show you empty summary statistics, and it won't calculate, it won't run the test. No, probably let me show you. Oh yeah, this variable ctryalp is a string variable. It could describe, but if you use, for example, something with calculations, look, well, this is the difference. You can use tab command, but so it doesn't work. And I don't, probably it shouldn't work with, at least in old versions of Stata. It didn't work. No, it works. Yeah, in this version. Anyway, I don't recommend you to work with string variables. It's a very unsafe strategy.
Okay, thank you.
Can I ask a question? How do we understand that our country has the value 371 or 372?
Oh, look, we have a variable country, right?
Yes.
You can describe it, top country. First, now we see Latvia, Estonia, okay? But what if we add an option no label? 371, 372 instead of words.
Okay.
Other questions? Well, okay, I have a question for you. Probably unexpected question. Do you feel that you are ready for our examination?
Well,
Can one be ready to something that he doesn't know anything about?
Okay.
you said that we will have oral exam, but during this session you said that during exam we should press the button of Walt, but how it possible? Or what type of exam we will have?
I think that you misunderstood me. We have
Maybe.
oral examination in accordance with to our schedule. That's it.
Okay.